Question 5. A, Part 1. State Hooke's law for 3 marks. Hooke's law states that the extension of a spring is directly proportional to the force applied to it, given that the elastic limit is not exceeded. This is, again, another easy 3 marks. Anytime they ask for a definition or a law, it's usually for 3 marks, and if you have studied, if you are prepared, those should be easy 3 points. Next, with the aid of a labeled sketched graph, explain what is meant by elastic limit. So this is what the graph of Hooke's law typically looks like. You have a straight line originating from the origin, and that shows proportionality, and up to a certain point it then doesn't have that characteristic anymore and starts to curve and taper off. That point is where the elastic limit should be labeled, and the elastic limit of a spring is the point whereby the spring will become permanently deformed and it will not go back to its original length, right? And the graph curving like that and no longer being a straight line shows that the extension is no longer proportional to the force applied. In other words, any tiny little amount of force will produce a great extension. Then, part B, we're told a steel spring has a spring constant of 2 times 10 to the second newtons per meter. We're to calculate the weight of an object which, when attached to the unloaded spring, produces an extension of 50 millimeters. And we're told that the elastic limit is not exceeded. And we're also given the formula that spring constant is equal to force over extension. So let's see, first thing we need to do is notice that the spring constant is given in units of newtons per meter, and the extension is given in millimeters. So we need to convert that millimeters to meters by dividing by 1,000, and so that will give you 5 times 10 to the negative 4 meters. Then we need to rearrange our formula to make force the subject, so force will be spring constant multiplied by the extension. Substituting our values, the meters and the per meters are going to cancel out, and we're going to be left with units of newtons. So when you multiply 2 times 10 to the second and 5 times 10 to the negative 4 using your calculator, that will give you 10 newtons. And that's the answer. Part C, we're told that the object attached to the spring in B fell from rest and hit the ground after 2 seconds. We're to calculate the velocity of the object on hitting the ground. So we want to calculate the final velocity, which is v. We're told that it fell from rest, so the initial velocity u is 0 meters per second. We're given to use the value of g equals 10 meters per second squared, so that's the acceleration due to gravity, and the time interval is 2 seconds. So we have v that we want to find, and we know u, a, and t. So the equation of motion we should use is v equals u plus at. Substituting our values, we'll have v is equal to 0 plus 10 times 2. So here, the second squared and the second, one of them will cancel and we'll be left with meters per second. And 10 times 2 is 20, plus 0 of course is just 20 still. So that's the answer. The final velocity v is 20 meters per second.